Hello students, I am Sonali Kelkar from City International School, and today we are going to do the revision of the chapter Gravitation. This is chapter number 10. So let's start the revision. Question number 1. Write the formula to find the magnitude of the gravitational force between the earth and an object on the surface of the earth. So we know that the gravitational force of an object uh, and the celestial body, what is the definition, right? It is nothing but the product of the mass of the two objects, and it is divided by the square of the distance between them. Now in this case we know that the object is present on the earth. So let me a little bit define what is over here. The situation is this is an earth, right? And the object is kept on the surface of the earth, right? So if we talk about the mass, so mass of the earth we can consider as m e, right? And mass of an object we can consider as small m, right? What about the distance? Because the object is kept on the surface of the earth, so I will take the distance as a center of the object and the center of the earth, that is the radius, right? So capital R will be taken as the radius, or if you want to take small r you can also take, but then you have to mention that the capital R or small r stands for what. Okay, so let's see the answer. Now the consider F is a force of attraction between an object on the surface of the earth and earth. Also consider M as a mass of an object on the surface of the earth, and ME, you can write E small over here, as a mass of the earth. Then we know that the gravitational force is equals to capital G is equals to G. This capital G over here is a gravitational constant, and I hope you know the value of gravitational constant. This is very important, children. So when you write the answer, I want you all to write the value of capital G. This is a gravitational constant, and the value of the gravitational constant is 6.67 into 10 to the power minus 11, right? And what is the unit? Unit should be Newton meter square, Newton meter square per kg small k, right? And g square. Fine. So this is all you have to write. Then you have to mention capital R, or in this formula there is a small r. So what is this small r? That also you have to mention. So this small r is a radius of an of earth. That is also you have to mention, right? Earth. Clear? So this is what you have to write in the answer. So this can come for 2 marks. Question number 2, what do you mean by free fall? We all know that when a body is allowed to drop from a certain height. Okay, so if there is a body, right, it is dropped to allow from a certain height, right? Then, and when the only force which is acting on this body is the force of a gravitation of earth, then we call then this type of fall is known as a free fall of an object. Now Earth's gravity attracts each object to its center when an object is dropped from a certain height. Okay, under the influence of gravitational force only, it begins to fall to the surface of the earth. Such movement is known as free fall, right? When you allow an object to drop from a certain height, and the only force which is acting on that object is the gravity, that is the gravitational force of earth, then such movement of an object is called free fall. Okay, so this word drop is very important. You shouldn't use any other word such as throw. Okay, don't use throw word, because when you're throwing something you are using your muscular energy or a muscular force which is which is not considered in case of free fall. Coming to the next question, what do you mean by acceleration due to gravity? So when we allow certain object to fall from a certain height, right? Suppose this is a height, okay, over here an object is allowed to fall. Definitely we see that initially the velocity is less, but as the object is going down, right, as the object is coming near to the surface of the earth, this velocity is increasing, right? Now what is rate of change of velocity? What do we mean by rate of change of velocity? Rate of change of velocity is acceleration, right? And because the acceleration which is happening in this case, it is due to the gravitational force of the earth, so we can say that this acceleration is nothing but the acceleration due to gravity, which is denoted by small g, okay, which is denoted by small g, and the value is 9.8 meter per second square. So this is the answer that you have to write in your portfolio, right? Write all the answers in your portfolio because this is a revision video. So you need to write it down in your portfolio. Now, how does the force of gravitation between the two objects change when the distance between them is reduced to half? Right now, here I'll tell you one thing. Okay, here we know that the gravitational force, right? Okay, now this is equals to the gravitation constant and the mass of the two object, product of the mass of the two object, m1 into m2 divided by the square of the distance between them, right? So in this case they have given that uh, the distance between them is reduced to half, right? So let's draw two objects. Initially the distance is this, right? The distance between the two objects is this, and later on it has reduced to half. Now this object these objects have come closer and distance is absolutely half. So if this is r, right, then this will be r upon 2, isn't it? We consider that r is a distance, right? So if this is r, then in this case this will be r upon 2. This is our first case, this is our second case. So let's substitute this in the formula. Now force is equals to g m1 into m2, and here we know that the distance is half. I can consider as half, or I can just write r upon 2, and we have to square it because it is a square of the distance. So when you square, what will happen? You will get g m1 into m2, and this will become r square upon 4. Clear? Now this is f, right? Now this particular denominator will get reciprocate, isn't it? It will get reciprocate. The 4 was, which was initially, this is g, the 4 which was initially down at the denominator, that will reciprocate. The 4 will come up, right? G m1 into m2 divided by r square, right? Now whole this quantity, we know this quantity is what? This quantity is nothing but force. So we come to the conclusion that this force over here, F, is equals to 4F. Okay, so what happened? This shows that if I reduce the distance, okay, between the two objects, if I make it half, then the force of attraction between the two objects will become 4 times, right? So hence, if the distance is reduced to half, then the gravitational force would become 4 times. Now question number 5. The earth and the moon are attracted to each other by gravitational force. Does the earth attract the moon with the force that is greater or smaller, or same as the force with which the moon attracts the earth, and why? Right. We all know that according to the Newton's third law, okay, the force of attraction between the two objects, it has to be same, right? They attract each other with the same force, right? If there is a earth, if this is earth and this is moon, the other object is moon, right? If earth is attracting moon with a certain force, right, that make it Fe, right? Moon will also attract earth with a certain force, that is Fm, and both the force are equal. Okay, so the earth attracts the moon, which associate a degree equal force with that of the moon attract the planet. However, these forces are in opposite direction, as you can see in this picture, that forces are in opposite directions, right? By universal law of gravitation, the force between moon and also the sun can be F is equals to G m1 into m2 divided by the square of the distance between them, right? Now coming to yeah, this we have explained, this I have explained already. Here you have to write earth, okay? The force between the moon and the earth can be F is equals to G m1 into m2 divided by d square respectively. Concept: action and reaction forces are always equal and opposite. So this is the basic concept of this answer. That is why the force between them are equal, but the direction is opposite. Now let's see question number 6. If the moon if the moon attracts the earth, why does the earth not move towards the moon? So we know that according to the second law of Newton's, okay, we know that the force is proportional to mass into acceleration. Now let's see how mass and acceleration are related to each other. So let's find out A is equals to, if I have to find out the acceleration, right, A is equals to, then m will go down or m will go under the F. So this is coming F upon m. So here you can see that acceleration and mass are inversely proportional to each other. They are inversely. Inversely, that means, what do we mean by inversely proportion? That means if one quantity increases, suppose if the mass is increasing, then acceleration is decreasing, right? And if the mass is less, then acceleration will be more, right? So these are called inversely proportional to each other. Now let's take the case of the earth and moon. If this is earth, right, and let's consider the mass of the earth, we know that earth is quite greater than the moon, right? So definitely the mass of the earth will be more than the mass of the moon. Clear? So if the mass of the earth is more, right, we know that how mass and acceleration are related to each other. So if mass is more, then the acceleration is less, right? So sorry, okay, if mass is more, the acceleration is less. So the moon, what the force is given by the moon on the earth, the acceleration is less, because this acceleration is less because mass of the earth is more. So that is why the acceleration produced due to the attraction of the moon on earth is less, whereas this case is opposite in case of earth. When earth, because the mass of the earth is more and the mass of the moon is less, so when earth attracts moon, the acceleration is of course greater, okay, it is greater. Clear? So that is why the earth not move towards the moon. It is, the acceleration is not that high so that it can attract the earth. Now let's see the answer. Yes. So according to the universal law of gravitation and Newton's third law, we know that the force of attraction between the two objects is same, however in opposite direction. This we have already discussed in the last answer, right? So the earth attract the moon with identical force. The force of attraction between the earth and the moon and the earth is same. But what about the acceleration? Because the earth has greater more mass, the acceleration is not that much, right? So it is not possible for moon to attract the earth, or earth won't come towards the moon. Concept inside: for the same force, an object with greater mass obtain less acceleration, right, as compared to the object with lesser mass. Now let's see the question number 7. What happens to the force between the two objects if the mass of one object is double? So in a very simple way we can explain that the first one, if the mass doubles, we know that force is equals to G m1 into m2 m1 into m2 divided by r square, right? Right. So if you have to find out the relationship between the force and the mass, one mass of one object is double, so you can write 2 into m1, right? m2 is all there, r square, right? And g is also there. So because I've double the mass of m1, so I can write 2 at front also. This g m1 into m2 r square is nothing but force, we know that, right? So if we see the relationship, this F is become 2F. That means the force has become double, right? So we can say that the force has become double. Or if I want to differentiate between the 2F, I can put dash. Okay, this F dash is equals to 2F. That means the force is getting double over here. If I double the mass of one object, right? Now what about the distance between the two objects is double and triple? So we know that distance is nothing but r, right? So let's find out how force is related if the distance is double, right? So that is G m1 into m2, because distance is double means r has become 2r now, right? So we know that 2r square, right? Or let's take it capital R, because we are dealing with capital R, so I'll write capital R, right? So this capital R over here. So you can see here that G m1 into m2, okay, into r square, right, is nothing but F, and this 2 into 2 has become 4. Okay, so F dash is equals to 1 upon 4F. Okay, so F dash is equals to 1 upon 4, which is F upon 4, right? So the relationship, the force has become 1/4, right? The force has become 1/4. Now coming to when the R get tripled, when the distance between the two objects gets tripled, that is 3R, right? So here also we have to consider G m1 into m2 divided by 3R whole square, right? And we know that 3R whole square is nothing but 9R whole square. G m1 into m2 divided by 9R whole square. This is F, right? Now this whole thing is nothing but force. So F dash is equals to, this is F upon 9. So the force has become 1/9, right? If you triple the distance between the two objects, the force will become 1/9. Now coming to the next, if the last one, the mass of both the objects are double. So here we can show that we know that the mass of one object is, what is the mass of one object? That is G. This mass has become 2m1 double and 2m1 m2, sorry. So both the mass is double divided by r square. So we know that G m1 m2 r square is nothing but F. So the F dash is equals to this whole the 2 into 2, I'll keep it out, I'll keep it aside, that is 4, and G m1 m2 we know that upon r square is F. So I can write 4F, right? So now the force has become 4 times. Okay, if you double the mass of each object, then the force will become 4 times. Now let's see the next question. What is the acceleration of free fall? We know that acceleration of free fall is 9.8 meter per second square, and it is independent of the weight of the fallen object, weight of the falling objects. Okay, so here is the answer. This acceleration is thought is this acceleration is thought the acceleration thanks to the gravity close to the earth's surface. This is denoted by g, and its worth is 9.8 meter per second square. It's constant for all objects close to the surface of the earth and irrespective of their masses. Okay, now what do we call the acceleration? What do we call the gravitational force between the earth and the object? Now we know that the pull of the earth towards the object is nothing but the weight of an object. Okay, so gravitational force is known as object's weight between the earth and the object. Now Amit buys 4 gram of gold at pole as per the instruction of one of his friends. He hands over the same. He meet him at the equator. Okay, will the friend agree with the weight of the gold bought? If not, why? Right. The hint is given, the value of G is greater at pole and than at the equator. Now in this case we know that the value of G is greater at pole, so weight of that gold will be greater at the pole. Okay, so when Amit buys a gold at the pole, as per the instruction of his friend, he has to pay more money because the weight is more. But when he came to the equator and he wants to hand over that gold what he bought, his friend found that the weight is less but the money paid by the Amit is more, so he was not agree with Amit, right? So here is the answer. The weight of a body on the earth's surface, we know that W is equals to mass into acceleration. W is equals to mass into m into g, acceleration, right? And we know that the earth is little flatter on the surface, whereas it is bulged on the center. So equator, this is the equator. If you see, the equator is little bulged, right? And the poles are little flattened. So we say that the shape of the earth is nothing but an shape of an orange. Okay, and we know that this small gravity, right, small gravity is equals to the gravitational constant mass of the earth divided by the square of the distance between them, right? So if we consider this, while considering this, we know that the distance and the gravitation is opposite to each other. The gravitation due to earth, okay, so it is opposite to each other. So we see that the gravitational force at the equator is less because the distance is more, right? So if G is less, right, at equator, so of course the weight will also come less, also weight will also be less because m into g, and this g is less, right? So weight will be less at equator, okay, at equator. Whereas because the distance is, this distance is less, so gravitational force will be more and acceleration due to gravity will be more. Here the acceleration due to gravity was less, right, at equator. This is equator and this is pole. So because acceleration due to gravity is more, so of course at pole, okay, so weight at pole will be, weight at pole, right, at pole will be more, okay. Why it will more? Because g is more, acceleration due to gravity is more, right? So this is the problem in this question, and due to this Amit's friend was not agree with Amit. Therefore Amit's friend won't believe the load of the gold bought, okay, or the weight of the gold bought. So concept inside is acceleration due to gravity changes from places to place or place to place. Next question, why will a sheet of a paper fall slower than one that is crumbled into a ball? Okay, I'll show you with the help of an example. Now this is a crumbled paper, right? And this is a sheet of a paper. Here you can see the surface area, right? Surface area is more when the paper is kept intact, right? The surface area is more, and if I crumble this paper, the surface area is, okay, is area is less, okay. So due to this the air resistance is more over here. Air is giving more resistance when the paper is intact, okay. The air resistance, okay, resistance given by air is more, it is more, whereas the resistance given by air, here the air resistance is less, here the air resistance is less, in case of this air resistance is more, right? So that is why this crumbled paper will come will fall down with a greater speed, okay. So a sheet of a paper has a lot of area as compared to the crumbled paper ball. A sheet of paper must face a lot of air resistance. As a result, the sheet of paper falls slower than the crumbled ball. Concept inside, amount of air resistance depend upon the cross-sectional area of the object. Now coming to the gravitational force on the surface of the moon is only 1/6 as strong as gravitational force on the earth. Okay, what is the weight of Newton's of 10 kg object on the moon and on the earth? If I ask you what is the mass of an object, okay, if the mass of an object is 10 kg over here on earth, and what will be the mass of the object on moon? So we know that mass is independent of the place, so mass remain same, it remains constant wherever you go in the universe, but definitely the weight will differ, okay. So weight is a vector quantity, mass is a scalar quantity, weight depends upon the gravitational pull, because what is the formula of weight? Formula of weight is W is equals to m into g, right? Now we know that this g, small g, acceleration due to gravity, it differs, right? It differs. So because this changes, because the small g acceleration due to gravity changes, so definitely the mass of an the weight of an object will change wherever you go. If you want to go from earth to moon or earth to Mars or to Venus, the acceleration due to gravity it will change, and as a result the weight of an object will also change, right? So let's see the formula. Mass and acceleration. So we will give the acceleration. Acceleration due to gravity on earth is 9.8 meter per second, right? and the weight of 10 kg object, we know that as we go on moon, the weight will become 1/6, right? So what is 1/6 of 10? So 1/6 of 10 we have to find out. So 10 multiply by 9.8 into 6, right? Or you can just write 10. This is the weight on the earth, then on the weight on the moon will be 10 upon 6. Why? Because weight becomes 1/6 on moon, right? And definitely you need to multiply by 9.8, which is the value of small g, acceleration due to gravity. Now if we solve this, we are getting 16.3 Newton. Remember children, the unit of weight is Newton and the SI unit of mass is kg. Right? So let's see the concept inside. Concept inside is weight of an object on moon is 1/6 of the weight of an object on earth. Now coming to the next question, calculate the force of gravitation between the earth and the sun. Given that the mass of the earth is 6 into 10 to the power 24 kg and the sun is 2 into 10 to the power 30 kg, the average distance between the two is 1.5 into 10 to the power 11 meter. So we have to use the formula because you have to find out the force of gravitation. So you should know what is the formula. F is equals to G. F is equals to G, mass of the two object. Here is the mass of the earth and mass of the sun, and the distance, square of the distance between them. Now you have to substitute the value. Value of G is 6.67 into 10 to the power minus 11, right? Multiply by mass of the earth, that is 6 into 10 to the power 24, mass of the sun 2 into 10 to the power 30, and the distance is 1.5 into 10 to the power 11 whole square. Children, don't forget to do the whole square, right? So when you are solving these type of questions, what you do, you solve these things first, solve the exponent first, right? And then you change the decimal sign into whole number, right? So 6.67 multiply by 100, you will get the whole number, right? And here 1.5 you have to multiply again by the whole number. So that 1.5 into 1.5, again you multiply by 100, you will get the whole number, 15 down, right? And you have to solve the whole thing. So ultimately you will get 3.56 into 10 to the power 23 Newton. Now let's see the next question. A ball is thrown vertically upward with a velocity of 49 meter per second. Calculate the maximum height to which it rises, total time it takes to return to the surface of the earth. Now let's see the height first, right? To find out the height, we know that when the object is thrown vertically upward, right? When an object is thrown vertically upward, it will come to a certain height where it will stop. So final velocity will be 0. The initial velocity is given here, which is 49 meter per second. Sorry, it's 49 meter per second. So initial velocity will be considered as 49 meter per second, that is u is equals to 49 meter per second, right? And this ball is thrown upward, so we have to find out the height. This is what is the height, which is considered as a vertical distance, is nothing but a height, right? And we know that acceleration due to gravity is 9.8 because it is thrown vertically upward against the gravitational force of the earth. I need to consider small g as negative. So it will be considered as negative 9.8 meter per second square. Now let's find out the formula. Okay, the formula will be v square minus u square is equals to 2as, right? Now let's substitute the value. We know that v is 0, so 0 square will be 0 minus this is 49, so 49 square, that is 49 into 49, right? I will write 49 into 49. You can also write 49 square. Then 2 into a. Now this a can be considered as g because a is nothing but acceleration due to gravity. So I'll write the formula v square minus u square as 2gs, right? Now this g is negative, so minus 9.8 student, okay? So I'll put it in a bracket, and s we have to find out. Now what is s? S is nothing but h, right? So I can write s or I can write h. So I'll write here h, right? So this formula, there will be a change, that is v square minus u square is equals to 2gh, right? You can take the original formula also, or you can take this formula also, right? But you have to know the changes, right? So this is minus 49 minus 49, and if I see this minus sign on either side of the is equals to, so it will get cut, right? So minus minus will get cut. Now I have to find out the value of h. So I'll keep the h on the left hand side, right? This 49 into 49, I'll put it in the numerator, that is 49 into 49 divided by 2 into 9.8, right? This is 9.8. Now if I have to remove this point sign, I need to multiply numerator with 10. Done. So now the point is removed. Now what can I do? I can multiply, I can divide 49 with 98, that is 2, right? And then I can divide this 490 with 4, right? And if you divide 490 with 4, you will get 122.5. 4 to the 8, 100 again 4 to the 8, and then 122.5. Yes, and this should be in meter. So 122.5 meter is the distance, right? Now we have to find out time. So let's see time. Now the total time. Now here this is very important. When a ball is thrown upward, right? The total time taken while the ball is throwing up, this total time while ascending is equals to the time while descending. Okay, if this is t, this will also be t, right? Okay, this both the times are same. So time at ascending and time at descending is always same. Sorry, it is descending. So just erase it. Descending means when the body is coming down, right? Descending means coming down. Here D. Now let's find out the time. So formula to find out the time is V is equals to U plus GT. So original formula is V is equals to U minus AT. So here we are going to do V is equals to U minus GT. Right? Why it is minus? Why the minus is G? G is minus. We know that because we are throwing the ball up. Right? So substitute the value. Initial velocity is U 49. Acceleration due to gravity minus 9.8 into TA. Okay, time to ascend. Now if we divide 4 divided by 9.8, so I'm getting 5 seconds, right? So how to find out? Now the time of descending, the time of ascending is TA is 5 seconds, and we know that ascending and descending time are same. So TB will also be, TD will also be 5 seconds, right? And then total time will be 5 plus 5, that is 10 seconds. Total time taken will be 10 seconds, right? 5 minutes for coming up, for 5 minutes for going up, and 5 minutes for coming down. Now coming to the next question, a stone is released from the top of a tower of height 9.6 meter. Calculates its final velocity just before it touched the ground. Okay, so why it is just before it touched the ground? Once it touches the ground, definitely the final velocity will be 0. So we need to find out the final velocity just before it touched the ground. Now I will explain you with the help of a diagram. Okay, if this is a tower, if this is a tower, right, and the stone is released from the top of the tower. Okay, the stone is released, and the height of the tower, the distance that you have to take is 19.6 meter, right? And when the stone is released, you have to find out the velocity, that is the final velocity v, you have to find out, right? Because it is releasing at the top, so definitely the initial velocity will be 0. So we need to find out final velocity. Height is given. Okay, time is not given, so we have to take the formula, that is v square is equals to u square plus 2g acceleration due to gravity and h, right? Why this is plus? Because the ball is coming down, so acceleration due to gravity will be considered as, that is acceleration will be considered as positive 9.8 meter per second square. So the original formula is v square is equals to u square plus 2as. So let's substitute the value. V square we have to find out, u is 0 plus 2 into 9.8 into 19.6. Now what is 2 into 9.8? V square is equals to 2 into 9.8 is 19.6 into 19.6. Now if I have to find out the value of V, I need to take out the root of 19.6 into 19.6. Now what should be the root of 19.6 into 19.6? That is V is equals to 19.6. What should be the unit? Meter per second, right? So children, this is all about today's session. Practice today's topic, and thank you so much.